Okay, so let's talk about a quiet revolution that's happening right now deep inside the batteries that basically power our entire world. We're witnessing a huge shift, a move away from the kind of messy chemical tech we've been using for decades and towards something that's way more stable, way more powerful, and, believe it or not, purely mechanical. And it really all starts with this surprising little secret. That battery in your phone, the one in your laptop, and especially the massive one in an electric car, well, it's all built around an unstable, volatile liquid. It was a pretty clever workaround for its time, but it's a compromise that has really defined and limited our technology for years. And that compromise has brought us to a really critical moment. You could even call it a crisis of chemistry. The lithium-ion battery that we all depend on, well, it's pretty much hit a wall. It just can't get much better than it is right now. And look, we're not just talking about small, incremental improvements here. We're talking about a hard, physical ceiling. Engineers can't just tweak the formula anymore. These liquid-based batteries are pushing up against their absolute thermal and safety limits. We are, for all intents and purposes, fundamentally stuck. So let's actually break down this liquid problem. At its very core, you've got these volatile organic solvents making up the electrolyte. That's the liquid soup that lets all the energy-carrying particles, the ions, flow back and forth. But this chemical mix creates a constant, persistent risk of fire. That forces engineers to build these heavy, complicated, and power-hungry cooling systems just to keep the whole thing from going into thermal runaway. It's inefficient, it adds a ton of weight, and it's just inherently dangerous. But the real villains in this whole story, they're these things called dendrites. Seriously, just imagine tiny, sharp, metallic needles growing right through the guts of your battery. As they get longer, they eventually puncture the delicate internal walls, which causes a short circuit. And that's when you get those fires you hear about. It's a direct result of using that unstable liquid. So if chemistry is the problem, what in the world is the solution? Well, it turns out it's a really brilliant shift in thinking. You move away from trying to manage a messy chemical reaction, and you move toward a simple, stable, mechanical solution. And the breakthrough is just beautifully simple. You get rid of the unstable liquid completely. You ditch it. And in its place, you use a super thin, rigid, solid ceramic separator. This simple physical barrier, well, it changes absolutely everything. I mean, the shift here is just dramatic. We're going from a liquid electrolyte to a solid separator. We're going from something volatile and unstable to something that's rigid and stable. Instead of trying to contain a chaotic chemical reaction, we're just using a clean, simple physical barrier. It's a total evolution in how we think about battery design. But here's the best part. This mechanical stability doesn't just solve the safety problems. It actually unlocks a whole new level of performance. So how does this whole solid-state advantage really work? It's really elegant. So first, that solid ceramic separator just takes the place of the liquid. Easy enough. Second, and this is the absolute key, its solid structure acts like an impenetrable wall. Those deadly dendrites we talked about, they just can't grow through it. It physically blocks them. And that allows the ions, the actual energy, to move through safely and efficiently with zero risk of a short circuit. And the impact on safety? It's just undeniable. The fire risk with liquid electrolytes is always there. It's always a major concern. But with a solid separator, that risk, it basically just vanishes. It becomes negligible. Now that is a game changer for literally every device we use, from the phone in your hand to the EV in your driveway. But, getting rid of the danger is only half the story. Always this newfound stability, this mechanical genius, it unlocks one massive, absolutely incredible benefit that is going to completely redefine what we think is possible. And there it is, twice the energy density. By completely solving the dendrite problem, we can suddenly use way more powerful materials inside the battery. We're talking about effectively doubling how much energy you can pack into the same space. Think about it. That means an electric car could have double the range. Or it could have the same range with a battery that's half the size and half the weight. That changes everything. And when you have double the energy density, the vision for our future suddenly looks radically different. This isn't just about making slightly better cars. This is about unlocking a whole new era of technology. This mechanical shift is the foundation for a truly electrified world. We're talking high-speed, long-range travel becoming totally normal. We're talking about electric vehicles that completely crush range anxiety for good. And we're talking about all of our devices becoming lighter, more powerful, and way more efficient than we ever thought possible. So let's just be crystal clear about this. This is not just the next version of a lithium-ion battery. It's not an incremental update. This is a complete evolution of the entire concept, a fundamental move away from unpredictable chemistry and toward the beautiful reliability of solid mechanical physics. Which, of course, leaves us with one final and really exciting question. When you have a power source that has double the energy and practically none of the danger, well, all the limitations we've been designing